छुट्टी है।
अच्छा, मैं आपसे पूछती हूँ, मुझे ना धर्मशाला जाना है, हम लोग दोस्त दोस्त जा रहे हैं, चार पांच चार जने जा रहे हैं, लड़कियां ही जा रहे हो। हम मजनू के टीले से लें बस, या फिर हम लोग धर्मशाला आईएसबीटी से लें कश्मीरी के?
आपको कौन सी बस पकड़नी है, एसी नॉन एसी?
हिमाचल टू एसी वॉल्वो पकड़नी है।
वॉल्वो पकड़नी है तो आईएसबीटी।
आईएसबीटी वहाँ बहुत मिलती है।
क्योंकि आप जो मजनू के टीले पे जाओगे वो तो वो
रुकती है,
रुकी रहेगी, प्राइवेट होंगी और उनका अलग है।
क्योंकि मेरे को किसी ने कहा कि मजनू के टीले में जाओगे तो ऐसे चलती चलती मिल जाएगी। मैंने कहा चलती चलती हम
ऐसे तो चलते चलते लाल किले के पीछे बतेरी बस जाती है। मैं उनसे परेशान के दो बार पकड़ी है वहां से, मैंने हाथ जोड़ लिया। इससे बढ़िया ये है गवर्नमेंट क्या वॉल्वो पकड़ो। हाँ, क्योंकि उनका सेफ भी है, स्टॉपेज भी सही है उनके। ये जो प्राइवेट वाले हैं ना, वो टोल टैक्स बचाने के मारे अंदर से जंगल के उधर से उतारने वाला, इसलिए गवर्नमेंट की पकड़। तो कोई है नहीं साथ में हमारे, तो उन्होंने कहा खुद पकड़ ली। मुश्किल नहीं है वो सब। आज में 270 रुपए की क्या दे आते हो? अभी आते वैसे नॉर्मल कितनी होती है? वैसे मुझे 190 की भी मिल जाती है।
All right. A very good morning to all. In today's session, I'm going to teach presentation of data under the postcode MPPC 05, quantitative analysis for manageable application. Let's begin from the sources of data, that is, the sources of data collection. There are two categories of data, that is primary data and secondary data. And more in general, statistical data are classified into two types of data, that is primary data and secondary data. Primary data are measured or collected by the investigator directly from the original source. It means the researcher has a responsibility to collect the data, or you can say collect the first-hand information directly from the respondent, and accordingly they use that data in or her research project, or you can see the research report for its own purpose to get some conductive or a meaningful evidence. When it comes to the secondary data, where an investigator or a researcher uses the data which has already been collected by others, that's called secondary data. In this category, the data are gathered or compiled from the published and unpublished sources like newspapers, magazines, unpublished reports, or the unpublished data in a online sources or the government reports. In fact, the articles or the literature reviews of different authors, that's considered as secondary data. So statistics are classified into two categories, mainly the primary data and the secondary data. Methods of data presentation. When it comes to the data presentation, is a graphical or a textual or a tabular representation of the, you can see, which of the number of observation within the categories or the values of the variable or the intervals. That's called the data presentation. There are three methods to cover under this topic, that is this textual method, a narrative description of the data gathered or compiled by a researcher, tabular method or the frequency distribution. It is a systematic arrangement of all information into the columns and rows. Graphical presentation, that is the illustrative description of the data, and that's called the graphical method. So there are three methods are classified into three methods, that is textual method, tabular method, and the graphical method. So these three most important methods are these three ones. Next is, let's come to the frequency distribution table. The frequency distribution table is a statistical table which not only shows the number of observation or the frequency, it also shows the defined classes where these number of observation comes or within that categories or the values of the variables or the intervals, and that exactly called the frequency distribution table. This is the parts of the frequency distribution table, that is heading, body, stubs or classes, which is called the class intervals, and the next one is caption, and accordingly you can put a source as well on the particular table. Frequency distribution. Frequency distribution is one of the techniques that provides all insights Okay. Frequency distribution is one of the techniques that provides a rich or depth insights into a data, and it's also lay down the foundation for more advanced analysis. The advanced analysis will be done through the frequency distribution table only, and without it the data cannot be analyzed or it cannot be displayed in the research report or article. What is frequency distribution table? It refers a list of categories or scores along with their corresponding frequency that called the frequency distribution table. Let's talk about again in the same two parts, the two main parts of the frequency distribution. The first one is the values of the variable, either quantitative or the categories if we talk about the qualitative variables. Like you can talk about the quantitative, it would be height, age, weight. When we talk about the qualitative, we talk about the awareness, knowledge, perception, friendship level, etc. The second main part of the frequency distribution, that is the number of observation, that's called the frequency, which is corresponding to the values or category. Let's take an example, the frequency distribution table, that the weight and the number of students. So when we talk about the number of observation or frequency, that is the number of students. When we talk about the category, we talk about the weight, height, age. It is irrespective or corresponding to their respective frequencies that called the number of observations. There are two types of frequency distribution, that is that we can say two main types of frequency distribution, that is the categorical, that is qualitative frequency distribution, and the second one is numerical or the quantitative frequency distribution. So we can talk about the classification of frequency distribution. In this particular category, the data can be classified according to the non-numerical categories. The categories must be a mutual exclusive and exhaustive. It used to present the nominal and ordinal data. So before I proceed into further upcoming slides, it is very important to understand what is nominal and ordinal data. Nominal data is a construction of a straightforward, it mainly known for the names and the, you can say, of a persons, or like for example the gender, the marriageable status. That's called the nominal data, where we are talking about the names of the particular category. Like for example, if we talk about the occupation, so it would be a student, a freelancer, a government employee, a private employee, even self-employed or other professional work. And that's called the nominal data. Here we are putting up name the category, and these are the names of the category of the occupation, that is freelancer, student, etc. So in this particular category, we have also taken one of the category, that is meritable status, where the particular options has been given, that is single, married, divorced, and widow. So it is a total of 60 candidates or 60 respondents, where the 25 comes under single, 20 comes under married, 8 comes under divorced, and the 7 comes under windowed. So that's called the nominal data, where we just take the one name of the variable and we just classify that or classify the categories of that variable, and that's called the nominal data. Second category is the ordinal data. Ordinal data, we are always talk about the ranking of the variable, the ranking of the classifications of the variable. Let's talk about, we have to measure or we have to find out the satisfaction level of the respondent. So we just classify the options or the you can categories of that the main variable, that is the satisfaction level, that is very satisfied, satisfied, dissatisfied, and very dissatisfied. Let's take an example. If you go to the restaurant, there is a feedback form where you can just fill up the answers of the question, that is to exact know the satisfaction level of the service delivery, satisfaction level of the behavior of the staff, satisfaction level of the quality of the food. So these are the options that the restaurant's feedback has been given, like very satisfied, satisfied, dissatisfied, and very dissatisfied, which aim to know the level of satisfaction of the customers or of the consumers. And that's data. What type of frequency distribution, what type of data is called the ordinal data, and that's called the qualitative data. And the category should be in a very organized, or you can say ordered manner, in a very systematic manner, which cannot be shift one particular category of the main variable to first one or the second one or third one. So whatever the organized order, the ordered manner has been given, that to be followed in the particular frequency distribution table. So when it comes to the satisfaction, let's talk, there are the total 80 respondents, or you can say 80 customers, where the 15 are very satisfied, 36 are satisfied, 3 are dissatisfied, and the 7 are very dissatisfied. Let's talk about in this particular frequency distribution, that is in quantitative manner, the data are classified according to the numerical size. They used to summarize the intervals and the ratio data. Interval that we use the class intervals data. In fact, we can use the ratio data as well. It can be a discrete or continuous series, depending whether the variable is a discrete or the continuous. Discrete, we refers the number of categories which is with respective or corresponding frequencies, and continuous refers to the class intervals with respective of their corresponding frequencies. So when we talk about the discrete, that is whether it would be ungrouped data or raw data, it can be shown in the following example, that in a survey of 30 families, the number of children per family was recorded and obtained the following data, and the raw data has been given to you. Now it is your responsibility that how to you can say arrange such data, such raw data, either in ascending order or descending order. So mostly when we talk about in the ascending order, you can opt the ascending. If the particular learner has to opt the descending order, he or she can definitely opt descending order. So there is no restriction that which order a particular learner or researcher has to follow. Any order can be followed, either ascending or descending order. So this is the particular question has been given, that is the number of children. So the number of children, that is the 2, 3, 4, 5, 6, 7, 8. So you can see there is the particular raw data has been arranged in the ascending order. So when we talk about there are particular number of children which has been given in the data, that is 2, 3, 4, 5, 6, 7, 8. So accordingly, the frequency is to be marked under or respective to the number of children. That is number of family 5, 7. So if you count 2, there are 5 in number. If you count 3, there are 7 in number. If you count 4, that is 8 in number. If you count 5, that is 4 in number. If you count 6, that is 1 in number. That is, or you can say 1 in frequency. That is 7, that is 2 in number. That is 8 and 3 in numbers. So if you see in the survey of 30 families, so number of family should be 30, right? And number of children which has been arranged in the ascending order from the raw data, that is 2, 3, 4, 5, 6, 7, 8. So that's called the discrete frequency distribution, where the particular researcher consider the one main variable, that is the number of children with respective corresponding frequencies, that is the number of family, that is 5, 7, 8, 1, 2, 3, and that will be counted from the raw data in the ascending order or descending order. and that's called the discrete frequency distribution, where a particular researcher has to count the number of times that each possible value is repeated, and that the data has been given to you and accordingly has been arranged in the ascending order, and a particular discrete frequency distribution table of 30 families has been shown in the screen. Let's talk about the continuous frequency distribution. The purpose of making this particular table is to select the set of intervals, whether it would be begin from 0 to 5, whether it would be begin to 10 to 15, whether it would become to 20 to 25, and that's called intervals, where the series has no end. So before come into a detail to describe this term, following basic terms you should know, that is range. In the particular you can say under range category, range term, it is refers a difference between the highest and the lowest score. If a particular draw data has been given, so what would be the highest value and what would be the lowest value? When you particularly subtract the lowest value from the highest value, that the value that we obtained is range. Next one is class interval, that is the abbreviation shows, that is K. It is a grouping, or we can see a category defined by a lower limit and the upper limit. Class intervals, we can see a difference or a grouping or a category between the lower limit and upper limit. Let's talk about the class boundaries, where a symbol is CB. These are known as the exact limits, where the 0.5 will be subtracted from the lower limit and 0.5 will be added to the upper limit. And that is the rule of the class, where is the rule of the class boundaries from the following data to obtain. So there are two categories in the, or two limits under class boundaries, that is the lower limit and upper limit. What is the lower limit and upper limit is? If we talk about the class interval is 0 to 10. So 0, where the beginning of a limit, that is the lower limit, and ending of the value, which is called the upper limit, that is 10. So if we say 0 to 10, so 0 is a lower limit, which is a beginning of a value, and the ending of the value, that is the upper limit. So that is 10 is the upper limit. So when it comes to the class boundaries, that how to calculate this class boundary, there is a rule that you have to deduct from 0.5 from the lower limit and the add 0.5 to the upper limit. So whenever in the particular practical question and how to calculate the class boundaries, when case of the continuous frequency distribution or case in the continuous series, so there is a class intervals which has been mentioned there. You just do subtract 0.5 from the lower limit and add 0.5 from the upper limit, and that's called the class boundaries. Let's moreover the class mark. What is class mark? Class mark is a middle value or the midpoint of the class interval. Let's take an example. It's the in class interval is 0 to 10. You have to add these particular limit, that is lower limit plus upper limit by 2. So that's called the mid value or midpoint, that is 0 plus 10 by 2, and that's called the middle value. That's called the midpoint. Let's take another example, 10 to 20. So what is the lower limit? 10. What is the upper limit? 20. And how to calculate the class mark? Add both the limits, 10 plus 20, that is 30, and divide by 2. Or you can say an average, right? Average, that is by 2. So when 30 by 2, it's called 15. So 15 is a middle value of that class interval, that is 10 to 20, or midpoint point of that class interval, that is 10 to 20. So that's called the class mark, and the symbol of that class mark is X. Let's talk about the class size of or width. It is a difference between the upper class boundary and the lower class boundary of a class interval. If you have already you can say know what is the class boundary. So whatever the class boundary, if you subtract zero point 0.5 from the lower limit and add 0.5 from the to the upper limits, when you find out the difference between the class boundaries, that's called the class size or width. That is in symbol W. So if we talk about let's say 1.5 to 10.5. So what is the difference between of this class interval 10.5 minus 1.5? So that is 8. So 8 is your class size or width. Next, come to the relative frequency, which denotes RF. These are the percentage distribution in every class interval. That means whatever in the particular question or in the particular continuous frequency distribution, if the frequencies has been given, then it is a very simple way to calculate the relative frequency. That is the frequency of each class interval divided by the total frequency. For example, if the particular frequency 5 of the respective class interval, that is 0 to 10. So 5 is a frequency, and what is the total frequency? Let's say 10. So 5 divided by 10, it's called relative frequency. Next, talk about the class frequency. Class frequency, it refers to the number of observations belonging to the class intervals. So if we talk about, let's say the height 110 to 120. So this is, and what is the number of students which comes under this class interval? That is 20. So 20 is your class frequency. So let's begin the question, a practical question where all these terms will be explained through numerically. So let's begin. The blood glucose level for 50 students is shown below. So construct a frequency distribution for the following data. Now question arises, this is the raw data has been given to you. Now you have to arrange this data into the ascending order. But before you decide, before you arrange into the ascending order, these are the following steps that you have to follow. First, to find out the range. Range is what is the difference between the highest score and the lowest score. Second, you have to calculate the key value, that is the calculator for the number of class intervals, that is k, using the formula. And this rule will follow when you construct any frequency distribution table if the raw data has been given to you like this on the screen. So k is equal to 1 plus 3.3 log n. And that is the rule here. This is a strong rule which has been followed while constructing the frequency distribution table. No other rule will be followed. The ideal number of class intervals should be 55 to 15. That means if you begin either from 5, if you end either from 10 or either from 15. So that's a way to calculate through this rule. The step 3, find the class width, and the formula is R by K. R is a, you can say, range, and K, what is K here? That is the number of class interval. So when you divide the number of class interval from the R, that you will get the width, that is class width. Then step 4, you have to start the observation as lower class limit and add width to that particular observation to get the lower limit. Then find the upper class limit, class boundaries, find out, tally the data, numerical values to write down, then calculate the cumulative frequency, then calculate the relatives. So let's begin the question. So this is the question given to you over here. So you need to find out the highest value and the lowest value from the data. So this is the particular explanation of this question. From the raw data, 90 is the highest value and the lowest is the 51 value. When you subtract these two values, you will get the range, that is 39. So when you apply the Strunch rule, so the overall value of the key is 8. So 1 plus 3.3 log 50. Why it has been 50? Because 50 families, we are talking about the 50 patients over here. The blood glucose level for 50 patients. So what is N over here? N is the number of patients, total number of patients, that is 50. So when you calculate the log 50, so whatever the value comes over here is 8. So log 50, the value is 1.69. So when you multiply 1.69 into 3.3 or add 1, you will get the value of K, that is 8. So when we talk about how to look up, that is, there is a log table which is also called the statistical tables. So from that particular table, you can check the value. Then accordingly, you can estimate the value of K. Under this question, the value of K is 8. Find out the class. The next step is class width. What is the formula of the class width? R by K. That is 39 is a range. When you divide the 39 by 8, you will get the width, that is 4.875, or we can, if you can round off also, that is equal to 5. Next step is 4. So when you get the class width, so you have, what is the lowest value? That is 51. So one by one, you just add class width, you will get the lower limits, right? I will repeat once again. Once you get the class width, because you have to prepare the continuous class intervals under continuous frequency distribution. So this is a way of the class limit or class interval, that is 51 to 55. By how it has been calculated, this is the way. Step 4. Step 4, how to calculate? Once to estimate the class width, what is the lowest value of the raw data? That is 51. So add 5 class width from to 51. 51 plus 5, 56, 56 plus 5. You will get 61, 61 plus 5, 66, 66 plus 5, 71, 71 plus 5, 76, 76 plus 5, 81, 81 plus 5, 86, and 86 plus 5, 91. What is these particular limits called? These called lower limits. So step 4, you need to calculate the lower limit of the classes. So if you calculate the width, you know the lowest value or lowest score. Add the class width one by one, you will get the lower limits. Now we have to step 5, we have to calculate the upper class limit. So once you get the lower class limit, you need to calculate the upper class limit. Either you can use this formula, or it is very simple to calculate the upper limit. Now the lower limits are 51, begin from 51. But obviously it will be and to be 55. Why it will and to 51 to 55? Because in the next series of the class interval, the lower limit is 56. So it means the first series of the class interval should be ANDed to 55. So that's called, so 55, 60, 65, 70, 75, 80, 85, 90. They are all lower limits. So just have a look. It is written in the particulars on the screen in the slides also. 55, 60, 65, 70, 75, 80, 85, and 90 are upper class limit. There is no need to use the formula to calculate the upper class limit. It is very simple. You need to calculate the lower limits, and from the lower limits you can easily calculate the upper limit. So if your lower limit is 51 and your second lower limit is 56, that means your upper limit ended to 55. That is called the upper limits. So this is one of the combined step of 4 and 5. This is the particular class interval and class limits which is shown here. Your 51 to 55, 56 to 60, and so on. That's called the class limits. In step 6, you need to calculate the class boundaries. So it's very simple. You already get the lower limit and upper limit. Just subtract from the lower limit 0.5 and add from the upper limit 0.5. So if you see on the screen, that is the 50, if you deduct 0.5 from the lower limit out of 51, you will get 50.05. When you add 0.5 to the upper limit, you will get 55.05. So this is step 6. So now you will get the class boundaries of the whole class interval. You can see the class limit. So just subtract 0.5 from all the lower limits, add 0.5 from all the upper limits. You will get the class boundaries over here. That is 50.5 to 55.5, 55.5 to 60.5. Even the most difficult part, you can see to estimate the or to formulate the class interval. So it is very easy once you use these particular steps, and once you calculate the class width, you can easily calculate the lower limit and upper limit. So it is one of the easiest way to estimate the upper limits and lower limits. So when you calculate these two limits, you can easily formulate the class frequency table. So this is the complete table step by step. The class limit, which is being already estimated, that is 51 to 55, 56 to 60, 61 to 65, and so on, which has been shown under the column A, that is class limit. The column B stands for class boundaries, which is already being calculated under the following steps, that is 50.5, that is subtract 0.5, which is a rule. I'm not saying this particular that you have to deduct 0.5 and add 2.5 to the upper limit. This is the rule under statistics, that how to calculate the class boundary. The rule says that you have to deduct 0.5 from the lower limits and add 0.5 from the upper limits, and that has been followed in a complete frequency distribution. So this is the particular class boundaries which has been followed up in the table, that is 50.5 to 55.5 and so on. And this is the frequency. How to calculate the frequency? It is very easy. Frequency will be calculated by telemarks. How to calculate the telemarks? This is an example. The first one is 51, and the class limit is 51 to 55. So 51, it comes under first class series of the class interval, that is 51 to 55. 65, so on, categories or series of the class interval. So one by one you have to telemark under the this particular class limits, and then you will get to know the frequencies. So there are four, that is four number of observations comes under the interval or class limit 51 to 55. There are three total, three in numbers comes under 56 to 60. 10 total in numbers comes under class limit 66 to 70. And how they calculate the frequency, you have to mark the tally mark that which number comes under class limit, which other numbers comes under different class limit, and accordingly the frequency has been estimated in this particular table. What is CF? CF is a cumulative frequency where the addition of the frequency one by one. So let's begin. Cumulative frequency 4. From beginning is 4, so it remains the same, follow the same number 4. 4 plus 3, 7. 7 plus 4, 11. 11 plus 10, 21. 21 plus 9, 30. 30 plus 7, 37. 37 plus 5, 42. 42 plus 8, 50. How to calculate the less than cumulative frequency? That is what is the total of the frequency? You have to subtract one by one from the cumulative frequency. 50 that we covered from the first class interval 50. 50 plus 7, 43. 50 plus 11, 39. 50 plus 21, 29. 50 plus 30, 50 minus 30, 20. 50 minus 37, 13. 50 minus 42, 8, and the 50 minus 50, 0. It means when you calculate the more than and the less than cumulative frequency, the and of the series of the class interval or class limit should be 0. Same in the relative frequencies. How to calculate the relative frequency? Frequency by the total frequency, that is 50. So one by one you have to divide and the values has been came out. Same for the relative cumulative frequency. It's very easy. There is no mean to to estimate. So relative cumulative frequency, the same way you have to follow to calculate the cumulative frequency, same way. 0.08, 0.08 plus 0.06, 0.14, 0.14 plus 0.08, 0.22, so and so on. You have it is easy to calculate the relative cumulative frequency. So when you came to know how to calculate the cumulative frequency, you can easily calculate the relative cumulative frequency. So once you calculate the relative cumulative frequency where the addition of one-to-one relative frequencies, then you will get the relative cumulative frequency. And another column which says if you need to calculate the more than relative cumulative frequency or less than, it is very simple to calculate. Subtract 0.8 from 1. Every digit you have to subtract from 1. So what is the total of the you can see relative frequency? That is 1. And what is the ending figure? That is also 1. So relative cumulative frequency, that is more than, so you have to subtract each value, each relative cumulative frequency from 1. So beginning should remains the 1, then add 1 minus 0.14, 0.86, 1 minus 0.22, 0.78, 1 minus 0.42, 0.58. The same procedure has to follow which you have calculated under column E, the same way to estimate under column H. So you have to subtract the total frequency from each cumulative frequency. You have to subtract the total of relative frequency form, and relative cumulative frequency form one that you have easily calculate under the column H. So this is called the continuous frequency distribution table. Now, what is the advantage and disadvantage of frequency distribution table? Either you present it graphically, either you present it diagrammatically, or tabulate in the tabulation form. It's understand the information very easily to make the data attractive. It is very easy to make the comparison and draw the attention of the observer. This is a diagrammatic presentation of data. There's categories into three parts: pie charts, bar charts, and histogram, which is also called the pie. You can see histograms, even multiple histograms like that. Pie chart is used to compare the relationship between the whole and its following components of the variables. And it is another way to display the discrete values or the discrete variables or the discrete values of the variable irrespective of their frequencies. So pie chart, as we can see, is a circular diagram or the area of the sector, which is called the 360-degree angle, which is always used in the pie chart. So let's follow up particular steps to construct frequency table. You have to change the frequency into the percentage or fraction, then change the percentage into the degrees, and the angle of degree, which is a 360-degree angle. The component part, it would be any colors, red, blue, green, the total of the frequency, and just into 360-degree angle. So whatever the value is to become, it is in degree angle, that is for 140-degree angle, 160-degree angle, 200-degree angle. So this is called the angle of sector. When you multiply the summation and division of the value, you will get the angle of sector of that particular category of the variable. Then draw a circle and divide it accordingly. So this is an example given to you: item of expenditure and the family budget. There are categories of the expenditure: food, clothing, and so on, and the family budget: 600, 100, 400, 100. So this is the item of expenditure. The family budget has been given, and the angle of sector, how it would be: 600 divided by 1500 into 360-degree angle. You will get the 140 angle. Same for clothing: 100 divided by 1500. What is the formula over here? Component part by total. What is the component part? Is clothing. 100 by 1500, that is a total, into 360-degree. You will get the 24-degree. So on, 30, 10, 96-degree, 24, and so on. How to calculate the percentage? In a simple mathematics: 144-degree by 360-degree into 100. You will get the 40%. 24-degree by 360-degree into 100, you will get the 6.67. So once you calculate and so on the same manner, you will get the percentage. Let's calculate the percentage of miscellaneous category, that is 72-degree by 360-degree. You will into 100, you will get 20. So that's called the whole, that how to calculate and how to make or estimate the values of different categories. In this has been shown in the following table on screen. So this is the diagram that make a circle and divide the categories according to their percentage. So percentage has been estimated. So it begins from 40, then 6%, then 27%, 7. So you have to take a predictor, you can see, and the degree. You have to mark accordingly, and this is a way to estimate the pie chart. So bar chart, it categorizes into simple bar chart, multiple bar chart, and a stack bar chart. It's just called a component bar chart or graph. Bar chart is used to represent and compare the frequency distribution of the discrete and the attributes or any categorical series. It is shown in the horizontal or vertical bins to represent the overall frequencies of the distribution or the categories or the intervals. So once you draw the bar chart, you have to consider these following points. Whenever possible, to construct a bar chart on a graph paper. Every chart either you can prepare on a graph paper or you can prepare on an answer sheet as well. So there is no difference at all. All bars drawn in a single study should be the same, where different bars should be separated by equal distance. So whatever the distance you will provide or give in the graphs, the same difference will be equal into a separate you can say categories. So all the bars should be the rest of the same line only, and the base should be the same. So whenever the possible, it is advisable to draw bars in order of the magnitude. So this is a way to estimate. So this is a question of simple bar diagram, which is only a one variable is to be considered. It is in the quantitative basis. The number of years has been given and the profit margin, which is millions in dollars. That is 10, 12, 18, 25, 42. That how to estimate, how to prepare this chart or graph, this is a way. So if you see the difference between the year wise is the same. And this is a way to construct or draw a particular simple bar diagram. X-axis would be the number of years and y-axis it would be the profit margins. So accordingly, you have to categorize. The lowest is 10, highest is 40. So you just begin from 10 to 15, 15 to 20 till 25 till 45 or 50. So this is accordingly, you have to mark the profit margins in the y-axis. X-axis, you have to mark the years, and this is the way you have to draw the bar chart, which is called the bars. And the difference between the bars should be equal. So this is a way to draw a simple bar diagram. So when you 1989 is 10, so just mark it 10. 1919 12, just mark it 12. Same for 18, 25, 42. That is called the simple bar chart. So when we talk about multiple bar diagram, we are not taking one variable, we are taking 2 or 3 variables as well. And it is mainly used to compare the variables, 1 or 2 or more variables. So this is a particular example has been given. Years from 1991 to 1995, there are 2 categories, that is imports and exports. The values has been given. The data has been taken from the Canada sources. So these are the values which has been given, import and exports in Canadian dollars. This is a way of calculate. So when we talk about 1991, you have to show in 1991 import bar and export bar graph also. So this is a way. So 1991, you have to show the both diagrams, that is export and import, and the coloring is also different. So when you draw an answer book or multiple bar chart, you have to make your own designs for the import and export rather than coloring. So when we talk about the values, that how has been estimated the value, you can say the import and export value. What is the lowest value of the overall data? That is 6150, and the highest is 12,150. So accordingly, you have to make your own values under this. That is 2,000 till 14,000, because the highest value is 12,000. So you can make a difference of 2,000 or 1,000, or you can say make a difference of 5, like say 5,000 to 10,000 to 15,000 to 20,000. Or you can take a less difference, that is 0 from to 2000 to 4000 to 6000 to 8000. That is a choice of a student, that which the you can see the take a gap of the values where the whole data can be represented. So that's called the multiple bar chart, which is shown in import and exports under the multiple variables in a particular year, that is 1991 till 1995. So if you take a difference of the values, less difference, and it covers the overall data well enough. If the less value is not sufficient to display the display in the particular data, in the particular graphs, so it's better off to take a more difference. It would be take a 3000 difference of all respective values. So that's called the multiple bar chart. Let's talk about the component bar chart. Component bar chart is represent or display the data where the total magnitude or the total values is divided into different you can say variables or the components. So this is a particular example has been given. So it is also used for the comparison basis as well. Year wise, it's 1991 to 1994 wheat, barley and oats. So this is the data has been given. So you need to find out overall from the overall data which is the lowest value. It is 13, and which is the highest value, that is 45. So accordingly you have to decide the values on the y-axis. So this is a way on the y-axis. So the lowest is 16. So begin from 0 to 20, 40, 60, 80, 100. Why to end it to 100? Because definitely the values is considered to be the 45. So you can take the 10 values also, 0 to 10, 10 to 20, then 40 to 50. But it is 100 to be taken because component bar chart is a cumulative frequency. So you have to add the values from 1 to 1 frequencies. So let's begin from 1991. Wheat is 34. Let's draw 34, which has been drawn in the red color. So how the yellow would be the second one? 34 plus 18. So that means it is 52. So you have to mark, but here it comes the 52. It's the ending of the yellow portion, that is between 40 to 60. So once you draw the 52, that is 34 plus 18, 52, mark it 52. That is the diagram, that is a part of the component of, you can see the overall wheat. Then when we come to the 52 plus 27. So 52 plus 27, how would it come? It is 79. So 79 has been drawn. So that's called the component bar chart of 1991. Same in 1992, we can say. So 43, just draw the wheat of 43 in 1992. 43 plus 14, that is 57. So just draw the 57 in the yellow portion. 57 will be marked. 57 plus 24. 57 plus 20, 57 plus 24 would be 81. So 81 has been marked. So it's just below, above 80. So that is the component bar diagram in 1992. Students might be confused that component, it would be separately, you have to draw 3 components under 1 year. No, component is a cumulative summation of the frequency which is shown in one bar chart of the whole years, or in the 1 year, or separately years of the 3 main variables. This is a graphical presentation of the data. The first one is histogram, which is one of the most important topic. Second one is frequency polygon, one of the most important topic. Third one is cumulative frequency graph, which is also called the Ogilvy curves, which is mainly used for the graphical representation of data. And the 3 main categories, histogram, frequency polygon, and cumulative frequency graph, is always applied into the continuous series. So histogram is a difference between the width and the length of the or number of observation within the particular val comes under the values of the variables. Frequency polygon is a mid points of the histogram, or you can see the given data comes under or showing in the histograms. Cumulative frequency Ogilvy curves are the graphs or a graphical representation which is mainly for used for the continuous data and based on the class intervals, which is based on the cumulative frequencies of the given variables. So this is a procedure to construct the statistical graphs. Draw and label the x and y axis. Choose a suitable scale, whether ordinal scale or nominal scale. It is very easy, and just mark it for x-axis or y-axis. Then class boundaries you have to check on, and Ogilvy curve or histogram accordingly, or frequency curve accordingly to be marked, which is already shown here, that frequency polygon drawn on the midpoints of the histograms. Plot the points and just draw the bars and lines to connect that points. So this is a way. Histogram is a graph which places the class boundaries on the horizontal axis and the frequencies on the vertical axis. Class marks and class limits we used as a quantity of x axis. This is an example. A raw data has been given to you. A same procedure you have to calculate to convert this raw data into the class limits, which is the following steps has been, I already taught you the same following steps to be followed under here. The same continuous frequency tables to be made again. So this is the way. This is the table has been shown. You just need to calculate the class width. Once you get the class width, you can easily estimate the lower limits and upper limits. So once you get the lower limits and upper limits, you can easily calculate the class limits. And from the class limits, you can easily calculate the frequencies, and you can easily calculate the cumulative frequency. This is a whole table I have explained to you, a solution of this particular question. 50 patient, so n is 50. Lowest value is 42. Width is 6. Class width is 6. So what is 42 is a lower limit. That means, sorry, class width is 7, not 6. So 42 plus 7, 49. Lower limit of the second series, 49. 49 plus 7, 56. 56 plus 7, 63. 63 plus 7, 70. So whatever the lower limits is come over here. Once you get the lower limits, you can easily calculate the upper limits. So where the second series of the class interval begins on 49, it means the upper limit ends below the value of 49, that is 48. So 42 to 48 is your class limit. Then your 56 is a lower limit. So in the second series of the class elements or intervals, what is the upper limit? It ended by 55. So that is 49 to 55 is your class limit. Class boundary, I already told you, subtract 0.5 from the lower limit, add 0.5 from the upper limit. This is a class mark. Then you have to mark of these values, 50 patients. So this is a class mark, you can accordingly add on. But when we talk about frequencies, how to calculate the frequencies, this you have to telemark. 44 comes under in the first category, class limit. 50 comes under the second category. 79 comes under sixth category. Yes, accordingly, you have to calculate the frequency one by one. Just mark it, add the particular values, you will get the frequency. Cumulative frequency is a summation of all the values, 8 plus 8, 16, 16 plus 13. And the same way you have to follow up in the previous table. The same way you have to follow up in the upcoming table, which is shown on the screen. So this is the graphical representation of the histogram. So this is the class limit and class boundaries. You can make the class from you can make the diagram from the class limit also, or from the class boundaries also. There is no problem, no question to be put on. So in this particular example, the class boundaries has been follow up, begin from 41 to 45 to 48. So just mark the particular class boundaries on the x-axis and the number of patient on the y-axis. But the number of patient on the y-axis depends upon the frequencies. Lowest value frequency is 3 and the highest is 13. So accordingly, you have to mark. That is 0 to 2. Take a 2 to difference, a small difference, so that the whole particular values comes under one graph. So that is 0 to 2, 2 to 4, 4 to 6, 6 to 8, 8 to 10, 10 to 12, 12 to 14. So accordingly, you have to mark according to the class boundaries. So let's begin. 8. 8 frequency comes under 41 to 45 to 48.45. 48.5. So this is a way for begin from 0 OX, begin from the origin, that is 41.5 to 48.5. So just mark your histogram. Then come to 48.5 to 55, that is again 8. If we look at on the second in class boundary, this frequency is 8. So this is a value. Then again you have to make a same difference, the width of the histogram, and the same procedure has to follow one by one class boundaries, and accordingly you have to mark the number of patients. So this is called the histogram, which is very easy to draw, which is very easy to calculate the values, but the most important is to first calculate the class width, and then you can easily calculate the class lower limit and upper limit. Very easy steps. So just follow up all the on the earlier slide the following steps. You will definitely easily calculate the lower limit and upper limit, and you can also make a frequency table in a very frequent manner, organized manner as well. So this is a frequency polygon, a line graph of class marks against the class frequency. So as I told you, what is the frequency polygon? Frequency polygon are the midpoints of the whole graphs or the whole values of the histogram. So histogram has been made. What is a frequency polygon is a midpoints of the histogram or the graph or the charts. That is midpoints. Just mark the midpoints of the histogram and just draw the line on the whole midpoints of the histogram, and that's called the frequency polygon. So this is a way to construct a frequency polygon, and these particular midpoints, these particular are the midpoints of the histogram only. So histogram is it's just drawn on the as you can see a line graph also of the class marks against the class frequencies, or in other words, we connect or draw the midpoints, and accordingly we just draw a line on the midpoints of the histogram, and that's called the frequency polygon. Next is Ogive in cumulative frequency polygon. It is a graphical representation showing the cumulative frequency, or in other words, it is calculated based, or it is constructed based on the cumulative frequencies which is being plotted against the upper and the lower class boundaries. So these are, and this class bound, and it is drawn on the basis of the class boundaries which is being plotted against the horizontal axis, and whatever the cumulative frequencies is plotted again along the vertical axis, that is y-axis. And what the Ogive curve which is drawn, which in other words we call the less than type, or the points that join by a free hand curve, and that's called the Ogive curve, or cumulative frequency polygon curve, or less than type curve. So this is a example which has been shown that frequency cumulative less than type curve or Ogive curve will be based or will be drawn on the basis of class boundaries. So class boundaries is very simple. It's a very simple way to understand. Subtract 0.5 from the lower limit and add 0.5 from the upper limit. draw on the x-axis. Y-axis is the cumulative frequencies to become and I already told you that how to calculate the cumulative frequencies. Just the addition of frequencies one by one, and that's called the cumulative frequencies. So just draw them and mark the points where the cumulative frequencies comes under the class boundaries, and just draw a line. That's called the OGIF, or in other words, we can call the cumulative less than type. So this is the OGIF cumulatives less than curve. That's it for today. Namaskar to all, and see you in another session, which is most important topic. Thank you so much. Take care. Bye bye.